Sometimes you may find it useful to have a member function in a derived class that overloads a function that's defined in a base class. Let's take a look at how this is done. Here I have a working copy of simpleinheritance.cpp from chapter 7 of the exercise files. And you notice we have this member function called speak in the base class, the animal class. And I'm going to come down here in cat, and I'm going to create another member function also called speak with exactly the same function signature. And I'll come down here and define the function. So now there's a speak member function or a method in cat, and that overloads the speak member function in animals. And so down here, when we call speak, you'll see what happens. I'll build and run. You see that instead of saying that the cat says meow, it simply says purr. Because sometimes when cats speak, they just say purr. So that's all well and good, and that works. But there's one important detail that we need to understand here. So I'm just going to come down here and I'm going to create an array of pointers to animal, like that. And then we'll cycle through those pointers and we'll call the speak method. I'm going to use the range-based for loop here from C++11 because that's fun and easy. So that calls speak on each of these pointers. Now, which one is it going to call on the cat? When I build and run, you see it says Fluffy the cat says meow. Because the pointer is typed as the base class, it will always prefer the base version of any overloaded members. To get the compiler to use the overloaded version, you can declare the base version as virtual. If I come back up here to the base and I say virtual right here, now when I build and run, it says purr instead. So the virtual qualifier tells the compiler that the function may be overloaded and to prefer the derived version rather than the base version. This allows the pointer to be polymorphic. Now this pointer, even though it's a pointer to an animal type, when it sees that speak function, it looks for a derived version in the pointed to object. Now there's one other important detail here. Whenever you declare anything virtual, you need to also declare a virtual destructor, just like that. This is not a hard, fast requirement, but many compilers will complain if you don't, and it's always a good habit anyway. The reason for this is that it's important that the destructor matches the function members so that when an object is destroyed, the appropriate destructor is called. So in this case, even though we don't have destructors defined, they're still default destructors. For the C object, the C destructor will be called, even though we're using actually all of these destructors will be called in the dog, cat, and pig classes rather than the animal class destructor. So now our pointers will work as expected. Overloading methods or member functions in derived classes is a fundamental part of object-oriented programming and especially polymorphism. This gives you a lot of power and flexibility in how you design your classes.